a vector across product of two vectors. Now, properties of vector products. So number one, A cross A is equal to 0. Now, if it is dot product, A is equal to A square or modulus of A square. But here, A cross A is equal to A square. Now, A cross B is equal to minus B cross A. That is, cross product is not commutative. Now, this is a scalar multiplication. So, this one is scalar. Alpha is scalar. So, A and B, they have what? They are two vectors, right? So, this scalar multiplied by A is the same thing as this scalar multiplied by B is the same thing as you take the scalar out, multiply by A cross B. Here scalar is the what? Real number. Then number 4, A cross open bracket B plus C is equal to A cross B plus A cross C. This is left distributive. This one is what? Right distributive. That is distributive property. Now, if A cross B is equal to 0 and A and B are non-zero, then A and B, they are what? They are parallel. You know, if A dot B is equal to 0, so that means A and B, they are what? They are perpendicular. But here now, A cross B is equal to 0 and A and B are non-zero. That means A and B are what? They are parallel. So I cross I is equal to J cross J is equal to K plus K, which is equal to 0. But in I cross J is equal to K, J cross K is equal to I, then K cross I is equal to J. Now, to mention few. Now, let's see geometrical interpretation of cross products. Now, let's theta B between the two non-zero vectors A and B. So, 0 less or equal to theta, theta less or equal to pi. Then modulus of A cross B is equal to modulus of A dot modulus of B sine theta, which is equal to area of parallelogram determined by A and B. So what we are saying in essence is that if you find A cross B, so if you can find the modulus of A cross B is the same thing as what? Area of parallelogram. So under application of vector products, we are going to talk more on this. Now, A cross B is orthogonal to both A and B. That is, A cross B is perpendicular towards A and B. So the direction of A cross B is determined by right hand rule. So if the fingers of your right hand curl through the angle theta from A to B, then your thumb points in the direction of A cross B. So this one is just showing the perpendicularity of what? A cross B to the direction of what? A and B. Is that okay? To the direction of both A and B. Now, let's look at first example today. So example 1. If A is equal to this, B is equal to D, show that A cross B is perpendicular to both A and B. That is, to show that A cross B is orthogonal towards A and B. Now, the first thing is to write A cross B. This formula, so you can write as a matrix form of order 3. Now, so let's put in the values of A1, A2, A3. So A1 is 4, A2 minus 3, A3 2. B1 2, B2 1, B3 then 5. Now, the next thing is to break this one into order 2. Now, you cancel the first column, first row. You are going to have minus 3, 2, then 1 and 5. This is it. Then minus J. So you cancel the first second column, right? So you are going to have 4, 2, 2 and 5. 4, 2, then 2 and 5, then plus K. First row, then last column this time around that you will cancel. So you are going to have 4 minus 3, then 2 and 1. Now, it's same thing as 3 multiplied by 5 multiplied by minus 3 is equal to minus 15. 1 multiplied by 2 is equal to 2. So it will be minus 15 minus 2. Minus J is here. So 5 multiplied by 4 is 20. Minus 2 multiplied by 2, which is 4. Then plus K into brackets 1 multiplied by 4 is equal to 4. Minus 2 multiplied by minus 3, that is minus 6. So minus 6 will give you plus 6. So minus 15 minus 2 is minus 17. This is minus 17 high. 20 minus 4 is equal to 16. So that's minus 16J. Then 4 plus 6 is equal to 10. That's plus 10k. This is A cross B. Now, to now show that A cross B is perpendicular to A and B. So, we're going to show the perpendicularity, to show that A dot A cross B, to show that they are perpendicular. Once you can find the dot product of A and A cross B. So A, this is A, then A cross B, this is the answer that we just, the answer for A cross B is this one. Is that clear? So let's find the dot product, because if the dot product is equal to 0, that means they are perpendicular. Is that okay? Now, we're going to multiply 4 and minus 17, minus 3 and minus 16, then 2 and then 10. So 4 multiplied by minus 17 will give you minus 68. 3 minus 3 multiplied by minus 16 will give you plus 48. Then 2 multiplied by 10 will give you 20. So minus 68 plus 48, that's 20, minus 20. Minus 20 plus 20 is equal to 0. This is perpendicular to what? A. Similarly, let's find the dots, this one. So if their dot product is equal to 0, that means they are also perpendicular. So this is B and this is A cross B. So we are going to multiply 2 and minus 70. That's minus 34. We are going to multiply, the coefficient here is 1. 1 multiplied by minus 16. Now it's minus 16. And the coefficient here is 5. 5 multiplied by 10 will give you 50. So minus 34 minus 16 is minus 50. Minus 50 plus 50 is equal to 0. So A cross B is what's perpendicular to B. So hence, A cross B is perpendicular to both A and B. Now, let's see another question now. Example 2. If A is this, B is this, so find A cross B, then find modulus of A cross. So to find A cross B, I think that one is for everybody, can do that one. So just substitute the values here into this formula. So we have 3 minus 2 and 1. This is 3 minus 2 and 1. Then we have 2, 4 and minus 3. This is 2, 4 and minus 3. So the next thing is to reduce this one to 2 to other 2. By deleting the first row, first column, you write this for the 4 values here. They are here. Delete the first row and the second column. So you have this the 2 values here and here. So we have the values here. Then delete the first row and then last column. You are going to have these 4 values. They are here, right? Now let's let's simplify. Minus 3 times minus 2. Minus times minus is plus, right? So we have 6 minus 4 times 1, 4. Minus j, minus 3 times 3, that's minus 9. Then 2 multiplied by 1 is equal to 2, so minus 2. Then plus k, 3 multiplied by 4, 12, minus 2 multiplied by minus 2, that's minus 4. So minus 4 will give you plus 4. So 6 minus 4, that's 2i. Minus 9 minus 2, that's minus 11. Minus times minus outside here is plus. So plus 11j. Then 12 plus 4 is equal to 16. So 16k. Is that clear? Now to now find the modulus of A cross B. So this is the answer for A cross B. Now to find the modulus of A cross B, so just find the square root of 2 square, 11 square plus 11 square plus 16 square. So let's see how that's one. So 2 square plus 11 square plus 16 square is equal to 4 plus 121 plus this is equal to square root of 381. Then let U be the unit vector perpendicular to the vectors A and B. Then U will be equal to A cross B modulus of A cross B. So which is equal to 1 A cross modulus of A cross B is square root of 381. Is that okay? So 1 over 380 square root of 381, then multiply by cross A cross B. So this is A cross B. 2i plus 11j plus 16k. So and this one is the unit vector perpendicular to the vectors A and B. So if this one is clear, so I would like you to practice this one. So if A is equal to this and B is equal to this, so find A cross B, then find minus B cross A, then compare your answers.